daily concept puzzle, because it's very important to cement the concepts we're talking about. So limits at infinity. What does the limit at infinity, or if you can give me an example? Limit at infinity. A little example. And what does the result? What most general case would be? So can anyone give us a limit at infinity?
If the limit at infinity or negative infinity equals a, then it has a horizontal asymptote of y equals a.
Yeah, so a limit that x approaches infinity, let's say from x squared plus 1 over 3x squared minus 2. So this is an example. Limits at infinity when x approaches infinity or negative infinity. So this is an example. What are we really looking for when we determine limits at infinity? For example, for a rational function, what are we really hoping to find? When we determine limits at infinity, what are we looking for?
Are we looking for the asymptotes?
Yes, which ones?
The horizontal?
Yes. So we're looking at horizontal or slant, meaning horizontal or slant. If it's a number, it's horizontal. If this limit is 5, it's horizontal, y equals 5. But if this number, I'm sorry, if the answer here is infinity or negative infinity, then it's a slant. Good. Infinite limit. What does the infinite limit mean? Or, and if anyone can give us an example. An example of infinite limit.
If the limit as x approaches a is infinity or negative infinity, then it has a vertical asymptote?
Yes. So the limit as x approaches 5 from 1 from the right, 1 over x minus 5. Yes, because the answer will be infinity. Exactly. Any questions here? Okay, so what is this limit? Oh, okay, so the result, what are we really looking for? What are we looking for?
The vertical asymptote?
Yes, we are looking for vertical asymptotes, yes. So that's what it is. So this is for VA. Good, as an example. Good. Can anyone give us the answer for this limit? Limit of 1 over x to power r, where r is a positive number. Tom, what do you think? Anyone? Landon, what do you think? Our test one is next week. Should I worry? Okay, Tom, are you with us? Dakota, Evelyn, Landon, Mason, anyone? So everyone is absent then? Nobody wants to say anything?
I just don't know the answer.
Okay. That's why I beg my students to go back and do the notes. always, okay. Let's take a look. Infinitely small or very small divided by large. Anyone?
Yeah.
0.
Yes, thank you very much. That's it, 0. Good. What about the square root of x squared? What would be the answer?
X.
The answer is the absolute value of x, which gives us two options, either x for greater than or equal to 0 or negative x for less than 0. So the square root of x squared has to be a positive number. So that's why we have to use the absolute value in case x can be any real number. So please remember this. So this is from our discussion on that among the last limits that we looked at. Right here. Maybe here. Maybe here. Yes. So remember, we just said that. So as x approaches negative infinity, this is very important because you cannot write x cubed. The square root of x to the sixth is negative x to the third when x approaches negative infinity. So that's why I was re-emphasizing this. Good. Can anyone give us the definition of f prime? Anyone? So we can write it here. Anyone remembers the definition of the derivative?
Is it the f of x plus h minus f of x over h?
There are two concepts put together. The most important two concepts that we discussed so far.
Difference quotient.
And the other one, yes, one of them is the difference quotient, of course. And the other one?
Is it the derivative?
Not yet. We haven't talked about the derivative yet. We just mentioned a few things. Two of the most important, yes. I couldn't hear you.
The limit.
Yes, I agree. So the limit as h approaches 0 from f of x plus h minus f of x divided by h. The derivative is not the difference quotient. It's the limit of the difference quotient. Perfect. A continuous function is not differentiable if who would like to answer, please? Anyone, please? I want us to move on together. I don't want to leave
It's
you.
not continuous, it's not differentiable.
A continuous function is not differentiable if
there's no rate of change.
yes. In which situations there is no rate of change? Perfect. Yes. Not differentiable means there is no rate of change. Awesome. But when are those situations?
Is that the cusp, the corner, or the jump? Are those the only three?
That will not be differentiable. Cusp, corner, and vertical tangent.
Vertical tangent.
If it's a jump, it's not continuous. Perfect. Awesome. Continuity implies differentiability. Yes or no?
No.
No.
The vice versa is true.
Yes. This is correct. Yes, but this one is not. Perfect. Awesome. If f of x is given to us in miles and x is in hours, what is the measurement unit for f prime?
Mass per hour.
Mm-hmm. Yes, the derivative is a rate of change, so it has to be miles per hour. Always, the derivative has 2 measurement units. Awesome. Great job. Any questions for me? The floor is open for you to answer. I'm sorry. Yes, to answer, of course, but to ask any question. If you need help with anything, please let me know. If you don't have anything right now and you find something else later, it's fine too. Does anyone need help with anything? Everything is okay? Okay, so in that case, I wanted to go back where we left off for 1 second. So I'm back here, last page, in which we identified continuous function. This is a jump, so it's not continuous. So as you just told me, Amanda said, cusp, corner, vertical tangent. Okay, so I would like us to work on the definition a little bit, find the derivative for several functions, and then we will move on to other examples. So just make up some functions. I would like us to determine the derivative for a, let's say, quadratic. Let's say we want rational. Let's also say radical. And I would like to start with the simplest one, which is the square root of x. And also here, I would like to start with the simplest one, which is 1 over x. And then we'll look at other functions. So can anyone give us a quadratic function so we can start with that? So for all these functions, we want to find f prime of x. So can anyone give us a quadratic function?
F of x equals x squared minus 5x plus 6.
Excellent. This is it? Good. So let's start with the quadratic function first. And we want to find f prime. Can anyone repeat the definition for us? Not Evelyn, anyone else? Because she already told me what the definition is. Can anyone give us the definition for a derivative function? Anyone, please.
F of x plus h.
Careful. 2 concepts put together. It's not the difference quotient. F prime does not equal the difference quotient.
The root of
Yes.
f of x plus h minus f of x plus
Yes. Yes. Awesome. Thank you very much. When h approaches 0. Good. So now we're going to work on f of x. So the only thing with a quadratic function that is somewhat difficult is finding this, because it requires some work and some algebra. So in order to find this for x squared minus 5x plus 6. So I'm just going to do this and it will wait. So can anyone tell us how to write f of x plus h for x squared minus 5x plus 6? How do I write that? And then we'll simplify it. Anyone else, please? Tom, are you with us? Mason, are you with us? Okay, just give us it's okay if you're wrong. It's okay. How do I write f of x plus h for this function?
X plus h squared
Yes, quantity squared, awesome.
minus 5x
Yes.
plus h
In quantity. So these are very important parentheses, plus 6.
plus 6.
Awesome, excellent, thank you so much. So can anyone square this for us?
X squared plus 2xh plus 2h.
Squared.
Sorry, h squared.
Very good.
Squared.
Minus 5x minus 5h plus 6. So now I have this. I'm jumping over all this, so please continue here. I have to copy the limit, so please do not drop the limit operator. instead of this, I will put all that. So I have x squared plus 2xh plus h squared minus 5x minus 5h plus 6. Remember, negative f of x means we have to distribute -1 to all those three terms. So minus x squared plus 5x minus 6 divided by h. Two things have to happen here. Can anyone refresh our memory on those two things? That if they don't happen, I'll say stop, stop, stop. Start from scratch. Something is terribly wrong. What has to happen right now? Because otherwise I can't continue. If it doesn't happen, then I have to say stop. What has to happen at this point?
The like terms have to cancel.
So the terms without h must cancel. If more terms cancel, that's fine too. It's great. So the 5x with a negative 5x, a negative 6 with a positive 6, and a negative x squared with a positive x squared. So the first thing happened indeed. What is the second thing that has to happen now? If it doesn't happen, I'll say stop. Something is terribly wrong.
Whatever remains have to be divisible by h.
So I have to simplify this h. So these three have an h in common, and that's how the h in the denominator will go away. So what do we have up here? So what do we have? So 1, 2, 3. I have to have three terms.
2xh plus h.
2x plus h minus 5. 2x plus h minus 5. Good. So after this goes away, these two, h approaches 0, I have 2x plus h minus 5. Can anyone give us the derivative of function x squared minus 5x plus 6? What is it? What is the answer now? Now the limit operator will be applied and it will disappear.
Would it be 2x minus 5?
That's it. So this function gives the slope of the tangent line or the instantaneous rate of change of this function everywhere. I normally have to say everywhere where the function is differentiable, but this is a polynomial function which is differentiable everywhere. By everywhere we mean everywhere. Why? It's guaranteed not to have cusps, corners, or vertical tangents. This will never, ever be not differentiable. So the derivative of that function is this. Notice that that is quadratic and this is linear. Okay. Moving on to the rational. The simplest one. Any questions before we continue? Any questions? Okay, so I think we should